Hey everyone, this is Dr. Walker. This is video 240. It's called Kirchhoffs rules, and specifically we're going to be discussing the junction rule. So to start off, we're going to see some circuits that cannot easily be reduced to one single equivalent resistor. We've learned how to simplify resistors in series and in parallel, but sometimes they're in neither of those combinations. For instance, if we take a look at the circuit on the left, we do have these two bottom resistors are in series. But after that, even if you simplify those to one and forget about this one here, there's nothing else that you can simplify. These two resistors over here, they're not in parallel because there's a battery in the way. Likewise with these two resistors, they're not in parallel because this battery is in the way. And they're not in series because there's a junction. So likewise, this crazy looking complicated circuit, you cannot simplify it down just using series and parallel. So when that's the case, we're going to use Kirchhoffs rules to solve these circuits. The first rule is a junction rule, and we've seen this one before. We're just finally giving it a name. We've seen that if you have a junction, the current in equals the current out. That's the junction rule. So in this junction, remember that's where two or more wires intersect, you have current 1 going into the junction and then current 2 leaving the junction, right? They point away from the junction. If we want an equation for this rule, we can call it the sum of the current in equals the sum of the current out. And you have to spell out this equation based on the currents in the problem. So in this case, the currents in would be I1, and the currents out would be I2 and I3, so you would sum those up. That's how you would write the junction rule for this particular junction. But, I3 here. Sometimes you might have I1 plus I2 equals I3, so it just depends on how the currents are labeled at your junction. Let's take a look at this question. The diagram below shows a segment of a circuit. What is the current in the 200 ohm resistor? So we have a 2.5 amp current here on top. We have 1.5 amp here, and we're looking for the current here. We don't need, we could simplify this circuit, but we don't need to because the junction rule tells us that at this junction, the current in, which is 2.5 amps, equals the current out. We have 1.5 amp coming out this way down, and then the current is drawn downward here. If it's going downward here, that means it's going to the right here because it has to follow. So it's coming out of the junction as well. So I in, let's call it I1 equals I2 plus I3. I1 equals I2 plus I3. So 2.5 equals 1.5 plus, and you can see that the missing current is 1 amp. So that's it for this short video. In the next one, we'll take a look at the loop rule, the other Kirchhoffs rule that we're going to need to be using.